Okay, so this is just a short video to demonstrate how potentially damaging this device can be if you use it in your car and accidentally short one of the modules or components, electrical components in your car. So this is a electrical testing probe for designed for auto diagnostics, and it usually has a probe here at the tip. I just replaced that with a banana jack. Anyway, I'm using the scale 12 volt tool battery here. I just have like a pair of screwdrivers here to this probe here, connecting the battery to the probe. And from the tip here, I have this yellow wire coming through this clamp meter. I have this clamp meter set to record the max current that goes through it, and I have it going through this clamp connected to this oscilloscope here, and this is going back. I'm shorting this yellow lead to the negative side of the battery. Wait, I disconnected that. Let me connect that quick. So that's the setup. Now I'm going to demonstrate that when I short the positive, essentially shorting the positive to negative through this probe. Ideally, it's supposed to have proper short circuit protection, a breaker circuit that instantly trips to prevent damage to components under test. In this case, we're going to see that it takes about a second, slightly more than a second sometimes, and it peaks to about 50 something amps, which can be really dangerous and can damage some sensitive, even not so sensitive components with that kind of current and taking that long before the breaker trips. And just a note here, this thing inside uses a PTC fuse, which is not ideal. I've seen some other devices that use an actual circuit breaker. In this case, it's using a PTC fuse, and the problem with PTC fuses is that it can take some time to trigger because they require a buildup of heat before they cut the circuit. So let me demonstrate now. When I get the oscilloscope is running, so when I press this positive side, you're going to see it's going to record a max current, and I'm going to show that this is not a transient, because you will see on the oscilloscope that 50 something amps goes on for quite a bit. So here we go. Then stop the oscilloscope. Okay, now you can see here that this clamp meter recorded 58.6 amps, which is really, really high. And then going to the oscilloscope here, let's see. So we can see here that we have a spike or up to about the same, like 58 amps, and then it ramps down slowly, and then once the fuse cuts out, it goes down. That's what you're seeing here. And I have this clamp set to 10 millivolts per amp, and here, let me put the horizontal measurement here. So if I turn on the horizontal here, we can see that it goes up to about 586 millivolts. That's showing there on the oscilloscope. This is not focusing. Well, it's about 586 millivolts, which roughly translates to 58, actually almost exactly 58.6 amps if you calculate based on the setting here. So, and this goes on for, we have a horizontal division here of 500 milliseconds per division. So it goes on for more than a second. Sorry about that. It goes on for more than a second. So this can easily damage something in a car. And yeah, just be careful not to short if you're using this device. Be careful not to touch anything. And if you do, just know that there's a very high risk of damaging something. Thanks.